In this section, we are going to talk about some proportionality theorems and how we're going to use them to solve problems. So let's take a look at the two proportionality theorems we're going to look at. The first one deals with parallel lines. So you'll see on here that we've got these two parallel lines. Let me highlight those for you. So we've got a parallel line here, and we've got a parallel line here. Okay, so those two are parallel. And what's going to happen with these is that they're actually going to divide these segments up proportionally. So remember what proportionally means. It means that they divide to the same ratio. Okay, so when you've got this piece, okay, versus this piece, and this piece versus this one, those are going to divide down to the same ratio. So like if this one was 1 and this one was 2, not really drawn to scale, then this one would, if this one were 3, then this one would be 6. Okay, so you can see that that they're double each other in this case, or if you looked side to side, this one compared to this one compared to this one, it would be 3 times bigger. So same ratio. The angle bisector proportionality theorem. So we'll see this angle bisector here. So you need to see that it's bisecting the angle, meaning splitting it into 2 equal pieces there. Then it's going to split this angle up proportionally with this side. So you're going to have the angle piece, okay, compared to this side, okay, so the two kind of sides of your angle, and then the chunks that they are split into are going to be proportional. Okay, so when I divide these and divide these, they're going to equal the same thing again. So this time, let me just put letters on here. So if I take x divided by y, that's going to be the same thing as w divided by z. They're going to divide down to the same ratio. Let's take a look at a couple of examples with each one here. So we can see that we have the parallel line proportionality theorem in this one, where we've got those two parallel lines. So now it's going to split these up proportionally, these sides up proportionally. So again, comparing this side to this side, this little piece to this little piece, you can kind of see the proportion happening here. Okay, if you can think of this as one of the sides and this as the other side, that's going to give you the proportion right there. Many of you know that I like to start with the x, so you can solve this one for sure. A lot of you know that I like to start with the x. So I would go x over 6. Okay, so then I went bottom to top on the left side, so I'm going to go bottom to top on the right side. So equals 5 over 8 and solve that way. I'm going to give you the same answer, right? So we can cross multiply here and get 30 equals 8x. Divide by 8 to both sides and get 3.75. So again over here, just to show you. So the reason I like to start with x is then I just cross multiply and divide. So cross multiply that diagonal and divide right away. So again, 30, 6 times 5 is 30, divided by 8 is 3.75. This one over here, so we can see those parallel lines again. So we see the parallel line here, we see the parallel line here. So those little pieces are going to be proportional. So again, this piece versus this piece, and then this one versus this one. So we've got the x over 2 on this left-hand side that we can do. And then over here, we have 5 over this piece. Okay, so we see the whole thing is 8. So this piece right here would be 8 minus 5 to get that leftover of 3. So x over 2 equals 5 over 3. Again, we can cross multiply and divide here. So we'll get 10 divided by 3. If you wanted to do the decimal form, that would be 3.3 repeating. Then two examples here of the angle bisector theorem. So again, let's highlight the angle bisector here. So then the sides are going to split up the sides of the angle versus the pieces that the angle bisector cuts the other side into. So if you want to start with the x like me, so I'm going to go x. I'm going to compare the x to the 9. So I went bottom piece to top. So then we're going to do that over here to the bottom one to the top. So 14 to 21. Cross multiply and divide. So 9 times 14 is 126 divided by 21, and you get x equals 6. All right, then this last one here, so we've got, again, another angle bisector. So then let's highlight the sides or put the sides together. So the 12 with the 8, and then this piece with this piece. All right, so let's start with the x. So I'm going to go x compared to, and this time I'm going to compare it to the 8. So they're both on the left side, which is fine. Okay, so we'll compare those. So piece to side on the left, so x over 8. And then over here, I need to do this piece compared to 12. Okay, so this piece right here, so again, just like that one on the other screen where we did, let me go back to it, where you took 8 minus 5 to get this piece, that's what we're going to have to do here, except for the whole thing here is 14, and the piece that we know is x. So that little chunk is going to be 14 minus whatever x is. Then we can cross multiply. So now this time we've got two x's, so we're going to have to actually cross multiply. So multiply it up to get 12x, and then multiply the 8 up to this whole piece. So do 8 times the 14 to get 112, and 8 times the negative x to get minus 8x. Add 8x to both sides to get 20x equals 112. Divide by 20 to both sides to get x equals 5.6.